Alright, so I have everything laid out, and I did realize that I am going to have to tap these because the through hole will interfere with the pivot bolt that this is going to pivot on. So everything marked out, and those two holes in there are going to be cross drilled to meet our pipe taps here. And we're going to start drilling this. So this one is going to be tapped for 1024, 3/4 of an inch deep, and this one here is going to be a straight through hole. So I'm going to run over to the drill press. I'm going to do this one off camera, and then we'll do this one on camera. Okay, so I have my block already all center drilled to set up. You get to see the 2 ports inside. These are the 4 bolts that are going to hold everything together. These are the 2 actual ports. One's going to be capped, one's going to end up with a 90. And this is going to be the through hole for the pivot. So what we need to do now is drill these 3/4 of an inch deep, because we're going to tap these by 1024. Because if I drill them all the way through, it's going to interfere with this bolt. So this side's going to be threaded, the other side's going to be a through hole. And these are for the 1/8 inch MPT taps, and those are just going to meet this port in the middle. So set this guy in my vise, and we're not going to bother drilling and then tapping right now. We're just going to drill these holes. We're going to drill all the holes, and we'll tap after. And I have the depth stop set on my drill for 3/4 of an inch. So. Okay, so this is going to be our piston here, and this is just 1.5 inch aluminum, and we want a piston to be about 1 inch long, and we need a face. So we're going to face this side, flip it around the 4-jaw, face the other side, and put a 1/2 inch hole in the middle. Leave the outside diameter unmachined. Then we'll figure out what our rod swing is on our rod, our actual piston travel, and then we can mount this on that rod, and then we can turn it directly on the piston rod, so we have a nice true diameter. So we'll just set up to face this here. I'm going to grab my glasses and we'll face this. just want to flip that around. Our indicator. Okay, we're all faced to length on that, which is 1 inch, and we're going to pop our 1/2 inch reamed hole in there, and this is on size, so this is a 1/2 inch reamer, so that way there I can get a nice fit and get some Loctite on that piston. Before we mount this piston in the on the rod from further machining, we need to put the check valve in there, and all it consists of is a steel ball retained by a screw with a slot in it. And this will allow us to return the saw to the upright position without having to work the needle valve. So what we're going to do is drill and ream an 1/8 inch hole in here, and we're going to go partially down about 3/4 of an inch, or probably about a 1/2 inch, with a tap drill for a 1/4 28 thread, and then we're going to thread that. So okay, so I got the cylinder together roughly. There's no O-rings in there yet. I still haven't trimmed the whole threaded rod and everything else. But basically, what we want to do is we want to figure out what the actual throw of the piston is going to be in here, because we want to get that piston equal on both sides. So we need to mount this first. So if you notice on this, probably from casting and stuff in the molds, you see you got an angle here, and an angle and an angle. Now the old handle mounted here and with another bracket here, and the spring went between here. This is the leg bolt hole right here. So what we have to do is we have to make up for that angle there. So if you kind of do this here, you can see how much of an angle is there, and I measured that, and it ends up being 3/8 of an inch. So what I got is now everybody's saw is going to be different. My measurements were way different than what was in the actual article. You can see I got a 3/8 inch piece bolted to a 3/8 inch plate, and I was able to hold this up. I was able to measure down and over and figure out where this hole is going to be, and lo and behold, I actually have a metric screw, a longer one. This is the original one that was able to fit right into that hole, so I didn't have to do any modifications on that. And then I just kind of poked in from the back side here to find the hole for a pivot. So for right now, what I'm going to do is just shove a pin in here, and we'll make a bolt for this, or buy a bolt or something, because we're going to have a little bit of a guide. So I think what I'll probably end up doing is just making it out of a piece of 5/16 brass or something like that. I still haven't quite decided on that, and just trying to get the hole in the leg lined up. So there you go. So that's going to be our pivot point, which is going to pivot onto this. Something in the neighborhood of that. okay? And you can see, if I hold this up here, that plate is pretty straight. It's not 100% perfect, but it's a lot easier using just a regular piece of 3/8 than trying to shave something down or go crazy like that. Now, over here on this bracket, let me move the camera for you. Right here is where the spring used to hook up into, and surprisingly, it's a larger hole in the back, and it's just about a little shy of 7/16 here, but it's bigger in the back. So what I was able to do is actually tap that for the time being for a 7/16 bolt, and we have our piston rod here, which we threaded the end 7/16 20, and we have a rod end here. So that'll be able to take up any kind of offset or anything we have on that. So basically that, and I'm probably going to have to adjust the size of this bolt, but that's going to sit like that, and that's where our piston is going to pull from. So now what I'm going to do is we're going to figure out the swing of or the extent of travel that this piston is going to get. So let me get the this rod into the cylinder, and we'll see how much of a distance we have of travel. Okay, so I have the actual piston rod in the bore, and it moves pretty good, pretty decent. It's got a few little rough spots here and there, but that's not that big of a thing. I can just take a little bit more out of here. I'm really tight on the tolerance. I can just loosen it up a little bit to let it slide a little more freely, but we definitely move. And so all I'm going to do is pop us on a temporary pivot, pull my rod back, and we're going to put in our temporary bolt. And I can already tell you right now I'm going to need a smaller bolt, or a shorter. I'm definitely going to need a shorter bolt than this, but I'm kind of just put it there for now. Get this in place. Alright, let me grab a marker. So right now we're at our extent in our vertical position here, so we're going to mark our rod. And I was going to indicate a U on both sides for up. And now we're going to let it down to its full extent. Which is there. And we're going to mark our rod again. And we're going to put D for down. Okay, so now we have our actual cylinder travel, and we can figure out where on that rod our actual piston needs to go. We got the cylinder all set there with the holes. We have our key here, or our retainer, slotted. I'll zoom in for you. Come on, focus. Alright, you can see the chunk taken out of that. Hopefully. There you go. Just did it with some files. And that goes right into there. And we got some good old steel balls here. And that's going to be our chuck. So, let me open this guy up. Pour one out. Oh, God. Oh, they're everywhere. Alright, let me pick up my balls. I was a little overzealous in my package ripping. Let me pick up balls for a month. So that guy goes in there. This guy here goes in the top. And grab my Allen. So that's it there. And if you shake it, I don't know if you can hear that. That's the ball moving back and forth. So the theory is pressure on this is going to push it that way to seal it. And then when we go to slide the rod back, it's going to open up and let the fluid through. Now, in the plans, it doesn't call for a spring. If this starts leaking by, they're going to have to put a spring in it, but we'll try it like they say. See what happens. Okay, so we got a test here. Nothing coming through. And this side here. Nothing really coming through. You got maybe a little bit, but not much at all. I mean, all that air you're hearing is coming out the blow off here, but that's what's coming through. And this way here. So it does work. Alright, so I have the rod marked out. I cut it and I face and center drilled it. So now we know where we want to put our piston, which is going to be smack dab in the middle of these two outside marks. So that's where we're going to put our piston, and then let me just line it up here. You can see our piston will be about here, and there's our movement. So our piston will move from here to here. Not much of movement. You can make a smaller cylinder, but like I said, we don't really know until we put everything together. So I'm going to clean this up in the middle. I'll clean up the piston, and what I'll do is I'll push it on there. Okay, so I measured the bore, and we're getting relatively consistency. 1 inch 470 thousandths. So this, I just mic'd this. This is 1 inch 505 thousandths. So we don't have that much to come off of here. So I'm going to go slow and sneak up on it. I don't want to overshoot it. And then we'll test fit it on the tube. Now we want a little bit of clearance. We want 1 to 2 thousandths of clearance. Our seal is actually going to be done by 2 O-rings, one closer to the front, one closer to the back. So we want a nice snug fit, but we don't want it to bind. So we want a nice sliding fit. Okay, so we got everything as a nice fit. And now we need to put our O-ring grooves in here, which I'm just going to do with the parting tool. I know these should technically have radiuses on them, but I'm not really worried about it. So I'm just going to come up and touch. I'm going to set 0. Our cutter is 90 thousandths wide, so I'm going to go in 90. And then we're going to set a 0 in, and we're going to come in 1/4 inch. 1, 2, 150 thousandths, and that's where our groove is going to be. So a groove there and a groove there. So we're going to plunge in, move outwards a little bit, and then plunge in again to finish our cut. What we want to do first though is we're going to touch our tool to the end there, and we're going to take dial indicator. Put it here. It's right here and I can read it. And we're going to go in 150 thousandths. So right now I'm going to set my 0 back out so we're not touching. I'll slow my lathe down. We're actually going to go in 120 thousandths. Bring my tails. Bring them in. Touch. 0. Back out. Okay, now we're ready. There's 100. There's 10. And 20. And back out. I'm going to go over. It's 120. Let me grab one of my O-rings that we're going to be using and make sure we fit nice and nice. Use just a scotch bit more room. Right about there. $120,000. Beautiful. Alright, so I'm going to do the same thing on the other side. I have to move my indicator. I really need to get another 2-inch travel indicator. This sucks playing with this one with a bracket. Okay, I'm going to touch there. Zero my indicator. Go over 90. Three zero. Go over 250. 1, 2, 50. Right there. Come in. Touch the tool. Put my indicator on my tool post, tighten it down, set it at 0, back my tool out, stop my lathe. 100, 110, 120. Back out. Unlock. Over here. Lock again. Back in. 120. And there are my O-ring grooves. So what I'm going to do right now is just take a file, deburr the outside edges of these, and then I'll put the O-rings in there, and I'll see if I have to go any deeper, see how much of a kind of a crush fit it has on that tube. Okay, so there are our O-rings, and we got a nice fit, nice and snug. So hopefully it'll make a good seal, and that'll work. So I'm going to put everything together, and I'm just going to connect that tube on the top with some copper and compression fittings, and we'll see what happens. Okay, so we're all set up and plumbed in. Of course, I forgot to get any kind of hydraulic fluid or anything, but I got some light motor oil, so I'm going to try that for now because I want to see this thing operate, and I know you guys do too. So we're going to fill her up. Fill her up. Ha ha ha, son of a bitch. Look at that. Ha ha. Look, it works. Okay, we gotta back this up and see it in all its glory. Alrighty, moment of truth. Oh, hitting the vise. Alright, it's pivoting in right there I can't move it. So it'll hold itself up. When we want to go down, open the needle valve a little bit. It's a little touchy once you get the weight on it, but you can stop it wherever we want. Still a little bit of air in the system I gotta bleed out, but look at that. Look at that. I am happy with that. Look, got a little bit of splooge. A little bit of Earl leak there. Everything else looks okay though. Alright, just got to fix this right here. That's where I said it might have been a little bit loose. I might have went a little too deep in the O-ring. But I could probably just get a thicker O-ring, pop that in there. But we're definitely looking good. And you can see that bypass is working. There she is. Alright, so we finalized the fit up. And I pulled all the oil out. And I went down to the auto parts store to get some regular hydraulic fluid, just some generic stuff. And all they had was gallons, and I wasn't going to buy a gallon, so I just got transmission fluid, cheapest one I could find. I think this was like $4. And so refilled the cylinder. So I did recut that O-ring groove. I had to go about, I went about 5 thousandths shallower than the one that was in there. And I wasn't getting a ton of fluid leaking out. It was mainly when it cycled, when it was under pressure. When it was sitting, it was fine. So it could be something that I did. It could be my screw up. It could be the O-ring itself that I used. I mean, they were from Harbor Freight, so there's a possibility that it may not be exactly on size. So we deviated from the plans here and there on the fit up here, and we had to make our plate size specifically for our machine. And as I said, we have a metric screw that went into the actual original hole that was there, and the hole that holds the leg to the base here we were able to use. And what I did was I took a piece of brass rod, 3/8 brass rod actually, and I turned it down for a nice snug fit in that through hole, and we threaded both ends of it and left this center section unthreaded. So this is a solid rod in this pivot, and we went into the hole here and bolted it up. Let me see if you can kind of see what we did in there. You know, if you can, that comes through there. And we got that all nice and snug, and I have a bronze washer here and here as our bearing surface for our pivot, so we're not going to wear into the aluminum. Makes for a nice surface. We have our needle valve, all that good stuff, and then up here we have a rod end, which would allow us to take up any misalignment we have with anything. This is like it'll be able to rotate and pivot, and that is going to be our actual pivot. You can see it's loose on the bolt. What I had to do is, this is a regular 7/16 bolt. I had to turn the very inside edge of this. It might have been from the zinc plating, but I couldn't get this to pull all the way up on it. So I just turned it down till it was a nice fit, and we put two nuts here, nylon lock washer nuts, one on the inside, one on the outside, and sandwich that together so that this bolt here doesn't move at all. It actually, the rod eye actually pivots directly onto that. And like I said, we're loose here to give us a little bit of play as we go up in case there's any misalignment with anything. And that way this isn't binding. You can see the thread stops there. You can get a full threaded bolt and run another nut all the way up and pinch this whole piece, but it's not really necessary. So again, we'll close our needle valve. We'll lift up, and then we'll let go. And you can see that holds. And then we'll just crack the valve. There's some slight movement there for maybe steel. We can go a little bit faster for aluminum. The only thing is this is kind of touchy. If you see the blade in that background, you can see how much I'm moving it to stop it. It's not that much, but it definitely gets the job done and works. You can see it goes all the way down. And no drips. So I'm really happy with this. And so thanks for watching these videos. Might split it up into 2 parts depending on how long it gets. And hope you enjoy these videos, and we'll see you on the next one.